Let's take a look at Ptolemy's model of the solar system. And in doing so, we're going to see two things. One, we're going to see that Ptolemy's model is quite complicated, right? We're going to see the complications that it has. The other thing we're going to see is how well it describes the observations that we see in planetary motion, namely retrograde motion and this elongation issue of Mercury and Venus. So let's start here. What we have, let me just introduce you to this simulation. So here's the actual model, right? And here's the sun. This is, in this case, Mars. We can make it to be any planet. And this is Earth. And there's there's a little guide in the bottom here, a key. Let's just look at that. So the blue dot is Earth. This is the planet, whichever we're looking at, and the sun. And then this little purple dot you'll see right next to the Earth. This says this is the center of the deferent, right? So this is the large circle is the deferent, and that's the exact center. And this little green dot is the equant, which is the center of the uniform motion of the epicycle around the deferent. So this particular epicycle that goes around, Ptolemy realized, wasn't actually centered on the center of the deferent, a little bit offset, centered on this green dot. Alright, so you get a sense that there are these little tweaks that Ptolemy had to make his predictions more accurate. And this is an interesting indicator because we'll actually see this reflected in later models where the mathematics of the model is more sophisticated. Alright, so that gives you a hint at some of the complications that Ptolemy had to include to make his model accurate. Alright, now we'll see here's the sun, and so we can animate this thing, right? And so we can say just start the animation, and we'll watch it go around a second, and you'll see the sun is going all the way around this loop. So before we look at the planetary motion, let's just look at the sun, and you'll notice that as the sun goes around over the course of a whole year, it's passing through each of the constellations of the zodiac, right? So that sort of represents the ecliptic that it's passing along. So we can tell the time of year by where the sun is in the zodiac. You'll see that also represented here at the bottom, right? So this is again like the whole year. This is the zodiac strip. All the constellations are labeled, and we'll see this S, this yellow S, passing through as it's animated, right? So you see the sun just kind of cruising by all the constellations. Alright, so let's actually watch the motion of this planet, which is set to be Mars here, right? So it's going around this epicycle, which in turn is going around this sort of deferent, right? And as we watch that, the curious thing that this really explains well, right, is retrograde motion. And you'll see that already in the path that's been traced out. Well, let's just watch it trace out another path. So Mars is cruising along, it's going circles on circles, but at a particular spot, it seems to turn around and go back the other direction, make this sort of loop, right? And this matches our perception of Mars in the sky, and we can see that here on the zodiac strip. So let's watch them go by, right? The sun just keeps on going. Now watch the planet, right? It goes, goes, goes. Eventually it stops, turns around, goes backwards, and then goes forward again. And that's the retrograde motion we observe in the sky. So this model is accurately explaining this retrograde motion, which happens at a slightly different time throughout the year. That's pretty good. In fact, we can see that as well if we change our preset here. Let's just change it to Jupiter. Jupiter also undergoes retrograde motion, but it does so much more often, right? And that's reflected by having a much smaller epicycle here. Right? And so we can watch Jupiter at the top. It's going around its epicycle on a deferent, and it undergoes this sort of retrograde motion. We can see it here on the zodiac strip as well. It goes forward a little while, turn around, does retrograde, goes forward again, right? So this is a way, this is sort of a mechanism by which Ptolemy is able to explain this retrograde motion. Now, retrograde motion isn't the only curious thing that needs to be explained, right? The other trick is this idea of greatest elongation, right? And the fact that Mercury and Venus both stay relatively close to the sun. They never get very far away. Now, looking at this model of Jupiter, we can see that at, say, this time of year, right, the sun is located here in Cancer, and Jupiter is way down here in Aquarius. They're on opposite sides of the sky. Jupiter does not have this issue. Its greatest elongation can be 180 degrees. The same is not true of Mercury and Venus. And so let's look at Venus and see how Ptolemy dealt with this. Now, at first glance here, this is now set for Venus, so we have Venus right here in the sun. You can see from the observer's point of view from Earth, Venus appears to be relatively close to the sun, so that's good, that's what it can do. But you'd look at this and you'd think, well, is it ever going to be possible for Venus to be on the opposite side of the sky as the sun, because that never happens in real life, right? So Ptolemy's model needed to be able to explain this. Why does it stay close? And so what he's done is he's essentially set, well, let's just look. We'll see what happens. Now you'll notice is that as from an observer on Earth, if you're looking at the orbit of Venus, you're always also looking at the Earth. So by setting in a sense, the circular motion around the Earth, by setting Venus's sort of, orbital period, you could say, very close to that of the Sun, then everywhere you look in the sky, and we can see this again in the zodiac strip, that Venus will always be relatively close to the Sun. So this matches our observations, right? So this is a good model, right? We could actually, in fact, it's better than we're even seeing here, because it could actually be used to accurately predict the exact location of the planets years into the future. So, which is amazing because it's doing this crazy dance of retrograde motion. So this is a very sophisticated model, and it explains our observations, which is why it lasted for so incredibly long.